Good day. Today we're going to continue on with the limits and finding limits algebraically, okay? So I'm going to go over the basic techniques. So for instance, the first one is the easiest, and I hope you come across this one, is simply called plugging in. Plugging in. Okay, I'll refer to it as plugging in. So here might be an example of that. You're asked to find the limit as x approaches plus 4 of 3 minus x. Okay, so, well, this is pretty easy. 3 minus 4. Okay, minus 1. Answer. You didn't have to do anything special here. You plugged in. Another version, which is referred to as simplifying. Okay, and simplifying can take on a few forms. One is called factoring. Okay, factoring. Another can be called combining terms. Okay, so we'll see both of these. So with factoring, I had another video earlier, and I showed the limit as x approaches 1 of x cubed minus 1 x minus 1. And this one here, you had to recognize that we were dealing with the difference of cubes, and there's a formula for that. And I made a mistake in that video with representing it, but I'm going to give it to you properly here. So this really is the same as the limit as x approaches 1, x to the third minus 1 to the third power over x minus 1. Okay, so here's the deal with these cube, expanding these cube factoring process. Okay, so we have a to the third plus b to the third. If we had that, we would get this. It would expand to this, a plus b, a squared minus ab plus b squared. Okay, we don't have that. We have this, a to the cubed minus b to the cube, where a is what? X, and b is 1. Okay, so we would expand this as a minus b, a squared plus ab plus b squared. Okay, and then so we'd recognize what we have. So we'd have x minus 1. Okay, x minus 1, x squared plus 1 times x, which would just be x, and b squared would just be what? 1. All right, so right away, this guy here would have been factored. This is the factoring technique. And then our limit, as x approaches 1 of x to the third minus 1 over x minus 1, then becomes the limit as x approaches 1 of x minus 1, x squared plus x plus 1 all over x minus 1. And as you see, and we, I don't know if I covered this very well in the last video, but I think I did. It was removable discontinuities. And so this here would be removed. Okay, so x minus 1 was removed, and this is referred to as removable discontinuity, aka also known as hole. All right, this is a hole. So if you've seen this in a function, the function would be coming in like this and then maybe going off like that. But at this particular x value right here, there's a hole. And it's a discontinuity. So you'd have to leave the paper with your pen to go over the hole and continue on with the function. So the function here is not continuous at this x number, right? Whatever that value is. And in this case, to get this value, you would set that factor, okay, this factor of x minus 1 equal to 0, and then you add plus 1 both sides, and you get x equals plus 1. So this number is equal to plus 1. At that location, this function has a hole, and it's removable as we factored it out. And so now what do we have? We have the limit of this above is now gotten us to this point. We never forget where we came from. We always keep track of what we have, in regard to the original function. We keep track because, as you know, there's a problem at this bottom if it goes to 0. So there's an issue there. Okay. So let's see what we have now remaining. We have x squared plus x plus 1. Okay. And that would just be, as x approaches plus 1, 1 squared plus 1 plus 1. And that would be 1 plus 1 plus 1 plus 3. And so we're able to calculate the limit by factoring. Okay. All right. There's another example here I want to cover with the combining terms. Okay. So in that example, we would have something like this. The limit as x approaches, say, plus 6 of 1/3 minus 1 over x minus 3 all over x minus 6. Okay? So something like this, we're combining terms. That's what it's called. So we're going to try to put this together, and we have to join these two at top by getting the common denominator. So to do that, I would use a different color pencil to just show you. We're going to make factors here and put 3 here and 3 on top. So we're multiplying this side by 3 over 3. We'll multiply this side over here by x minus 3 over x minus 3. Okay, so we have all that together. And then this will give us the limit as x approaches plus 6 of x minus 3, okay, all over what? This thing will combine and just become 3 x minus 3, okay, x minus 3 minus 3, right? So I believe that's what we get, right? So x minus 3 times 1 minus 3, so minus 3. Okay, so here then we end up with this here. Oh, all over x minus 6. I didn't forget that yet, right? So what we find out is this here is x minus 6, okay, over 3 x minus 3 over x minus 6. Well, guess what? You have x minus 6 in the top, x minus 6 in the bottom. So these two factors are going to become 1 and 1. And what remains is the bottom. And you have x goes to plus 6 of 1 over 3 x minus 3. Okay? And when this is calculated out, I put the 6 in here. I get 1 over 3, 6 minus 3. 6 minus 3 is 3. I get 1/9. Okay? 1/9 right there. And so that would be combining terms example. All right. Onward. We're on to the third way of doing this is called rationalizing. All right, how's that going to work out, right? So I'm going to say this is the third technique, okay? There's no numbering system to it, but I'm just assigning a numbering system to it. Okay, so second, first, second, and this is the third, rationalizing. All right, what are we talking about here? All right, in this case, we're referring to a fraction, okay? If we have a fraction with a square root in it, okay? A square root in it. Then in that case, we're going to have, here's an example, the limit as x approaches minus 2 of the square root of x plus 11 minus 3, all right, over x minus 2. All right, we're going to multiply. See, we have a fraction with a square root in it. So, okay, I see where I made the error here. This is a plus 2, so that's what I was getting confused. So if you actually put this negative 2 in here, it would be a problem. So that's why you're going through these extra steps. All right, so we're going to multiply this guy here by what is referred to as the conjugate. Okay, and the conjugate will look like this. So here's what we have. We have the square root of x plus 11 minus 3, x plus 2. We're going to multiply by the conjugate, square root of x plus 11 plus 3. See the difference? Minus goes to plus. Okay, so, and then we complete this by putting x plus 11 plus 3 on the bottom. So it's really, you're multiplying by 1. It's not affecting much. But you'll see the outcome will be pretty good. So we're taking this whole factor times this factor. Okay? So you're doing FOIL, basically. First times for inner, right? First inner. So we have, when you have this guy here is to the half power times this to the half power, you get something here to the whole power. So you just get x plus 11. All right? That's your first product. This one you get plus 3 square root of x plus 11. That'll be that. Now you get here minus 3 square root of x plus 11. And then you get finally minus 9. Well, you notice these two guys cross out. And we're just left with this. Now we have on the bottom, you have x plus 2. Okay. And then the square root of x plus 11 plus 3. So that has to be multiplied yet. We didn't complete that process. All right, so now I have to finish this here. And I'm going to put together, well, what does this become? This becomes x minus 9 would just give me what? An 11 minus 9. This whole top here is just going to become x plus 2. Okay, so these two combined together are going to give me x plus 2. And guess what happens to those two? They're gone. And now I have here, the result is the limit as x approaches negative 2, okay, of 1 over square root of x plus 11 plus 3. All right, and I put in the value, and I get 1 over negative 2 plus 11, okay, plus 3, and this will be square root of plus 9 plus 3 is, well, you figure plus or minus 3 plus 3, okay? So if you go minus 3, then you'll become undefined. So if you use the minus 3 plus 3, you get undefined. So that won't work. So you have to use the plus 3 plus 3. You get what? 1/6. So it's plus 1/6 is the answer. And that's the way that rationalizing goes. All right, so there's two other methods. They're quite easy to mention here. And one of them is a calculator, okay? So you would use a calculator and run the number. So if I have the limit of the one above, as you go to 1 of x to the third minus 1 over x minus 1, you would put in numbers to the left of this number and to the right of this number. So if this is 1, you would approach it and you would get closer and closer to it and see what number you get, okay? So for instance, you would put in, to start with, something to the left of plus 1, okay? So that could be 0.9, and then so this would be your x value, okay? So your next x value or test would be 0.99. You're getting closer and closer, okay? And you could even go to 0.999, okay, as you get closer to this plus 1. As you approach this number from the right side, okay, you would be at a higher number, and that would be, say, 1.1, and then you would do 1.01. You see how I'm getting, so this would be my x2, this would be my x, well, in this case, x3, x4, you know, more x's. I'm going along here. As I'm approaching, I'm getting closer and closer, and then your y output would give you something that would get to what the answer was as we had above, which would be minus 1. And so even though it wouldn't be defined here, it's undefined, okay, undefined at this value, we would start to get something like negative 1, something like negative 0.9999, and over here negative 0.999. You keep getting a value that is closer and closer to negative 1, and then you assume it's negative 1. You're from the left side, you're getting a number that's approaching the same as the right side, so we say the limit exists, okay, and the value, and its value equals minus 1, okay. Calculator, you could also use a graph, okay, graphing tool of some kind, and if you zero in on that number, you approach that number from the left and from the right, and you see it's undefined right here, but as you're right, if you kind of look at what would happen, this value would end up being negative 1, and that we call L, the number, the y value at where this hole would be, at what this hole exists at, I think, plus 1, right? That's where the limit is that we're talking about. So this value would be minus 1. Even though it's undefined, we get closer and closer, and we never really get there. But if we got so close, we would see from the left and from the right, the value is equal to negative 1. And the way we depict this is the limit as x approaches plus 1 from the minus side of x to the third minus 1 is x minus 1 equals minus 1. The limit as x approaches plus 1 from the plus side, that's this side. This is the minus side, this is the plus side, so this refers to this. And this refers to this side, approaching from that side, is also equal to minus 1. And so we say the limit exists. So we say the limit as x approaches plus 1 without using the plus or minus after the number, okay, then we just say it equals minus 1. And that's the way this is done. All right, thank you for bearing through this video. Have a good day.